everyone, Katrina here, and welcome back to my channel. Today we're going to learn how to use first principles to find the derivative of any function. In my previous videos, I showed you a bunch of other derivative rules that we can use. However, today, when you use first principles, it can be applied for any type of function. It shows you the fundamental way how to find any derivative. So I want us to take a second and look at this graph I have up here. This shows some function from some point x all the way to some point x plus h. Right now, this represents the average rate of change. However, to find the derivative, we want what is called the instantaneous rate of change. So that means that we want to get x, which is this term over here, and x plus h, this term over here, as close together as possible. So in order to do that, we can see that we want this h value, this value that's separating our two numbers, to approach 0. So we want it to get as close to 0 as possible without actually getting there. And this is the theory behind using first principles to find the derivative. So now let's take a second and look at the actual equation. So like we said, the derivative equals the instantaneous rate of change. And this equals to the limit as h approaches 0. So again, we're sending our h value as close as possible to 0 without actually getting there. And then it's the function f of x plus h minus f of x all divided by h. So let's look at our plot again over here. So we want to look at the difference. What is the point of our function at f of x and our point of our function at f of x plus h when h gets really small? So instead of the average rate of change, we want to find that instantaneous rate of change. So let's look at this in another lens. So the instantaneous rate of change equals the derivative, which we mentioned. And again, what is the derivative? The derivative is the slope of the tangent at the point. So slope of tangent at any point of the function. So it gives us, again, a function for the slope of the tangent at any point of our function. So we can go along our function over here and we want to figure out, let's say, what is the instantaneous rate of change over here. If we calculate the derivative, it will give us the slope, the equation for the slope of the tangent at that point. Let's do an example, and that will help clarify any further questions that you may have. So for example, let's start with f of x equals to x squared. And we want to find the derivative. So let's go and use first principles to find it. So we're going to use the f prime notation. So this notation represents the derivative of a function. And let's write out our first principles equation. So we have the limit as h goes to 0 of f of x plus h minus f of x all over h. And our f of x equals to x squared. So let's input that in. So this equals to the limit as h goes to 0 of x plus h all squared minus x squared over h. We now want to expand this and then simplify it to see what we get. So we have the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. So let's see what we can do to simplify this equation. Here already, see that these two cancel out, and then we can also factor out an h from the numerator. So now we've got the limit as h approaches 0 of h on the outside. Then we have 2x plus h all over h. Okay? And now we can see that these h's cancel out. And what do we have? Now we're left with the limit as h approaches 0 of 2x plus h. And now we look like we're in a pretty good spot where we can solve this limit. So in order to solve this limit, we're going to input this value of h into our function. So this equals to 2x plus 0, which equals to 2x. There you have it. You've used first principles to find the derivative of this function. So if you're familiar with my other videos and the power rule, we can see how in one step we could have gotten right from our first function all the way to our derivative using the power rule. But it's always good to know what is the fundamental way how to find derivatives, and that is first principles. So I hope this video allows you to gain a deeper understanding of what a derivative is and how to use first principles to find the derivative. So again, this gives us an equation for the slope of the tangent of any point along our initial function. Anyways, if you enjoyed this video, please drop a like and comment any questions below. I'm happy to go over other examples using first principles. And please subscribe for more videos, and I look forward to seeing you next time.